Section 12.6, last section of chapter 12. Here you see a bunch of equations, log equations that we need to solve. And I have the solution for you. So the first several pages are a statement of the problems. Now, problem number one, we want to solve 2 to the power of 2x equals 16. So again, we are using this formula that if you have a log and log of a with base of b equal to c, remember a, b, and c can be any numbers or any variables. You could just, what you have after the log, you write that first, and then you take the base and raise it to power of that. Now, for this one, we don't really need to do that because 16 is 2 to the 4. So if you have like a to the x equal to a to the y, if the bases are equal, then numerators are the same. You know, it's like if you have x2 equal to 4, 4 is what? 2 to the power of, I'm sorry, let's say you have 2 to the power of x is equal to 8. 2 to the power of which number is 8? You know, that number is 3, right? But the other way to do it is you just, instead of 3, you write 2 to the power of 3. If bases are equal, then numerators are equal. X equal to 3. So the same idea is here. 16, if I break 16, is 2 to the power of 4. They both have the same base, and 2x is equal to 4, x is 2. Now for this one, we do it backward, means you already have this part, and you want to change it to that, okay? So log of 22 with base of 5 is equal to x. Why? Because 5 to the power of x is 22. So it's like you do it backward on these equations. And then how do I calculate log of 22 with base of 5? Remember, if you have log of m with a different base, if the base is not 10, then it's log of m over log of n. And then you use your calculator and find each of these and divide. Same thing for that. You have given this, which is this part. You want to write it like that. So it would be log of 7 with base, log of 7 with base of 5 is equal to that. X minus 2 is, so I use my calculator, I find log of 7, I find log of 5, divide these two, that would be 1.209. So now I have x minus 2 equal to 1.209. If I move 2 to the other side, then would be that. The same thing for natural log, okay? So like if you have natural log of, let's say a equal to c, remember natural log means base is e here, okay? You don't have to write that. So you write this as natural log of 0.97 with base of e is equal to that. So I calculate natural log of 0.97. All I do is use my calculator as ln, right? You calculate log of 0.97, which is that number. So now you have equation minus 0.72t is equal to that. Divide both sides by minus 0.72. That gives you the value of t. Okay. First, we need to divide both sides by 3. Now, this one, again, we are using the formula, which change it to natural log of 4 with base of e, which we don't need to put that, equal to 4x. See, 4x. E to power of 4x is 4. So 4x is natural log of 4. 4x is equal to natural log of, I use my calculator. Natural log of 4 is this number. So now I have 4x is equal to 1.386. Then I divide both sides by 4. That would give me the x. And they want us to do 4 decimal places, 1, 2, 3, 4. Same thing. X is 2 to the power of 1. X is, what's the base for natural log? E. E to the power of 7. If you don't see any base for log, means base is 10. So x is 10 to the power of 1.7. Again, if you don't, natural log means base is always e. E to the power of 3. This one, first we divide both sides by 3. And then x is e to the power of -4, which is that number. And remember, you could always pause the video if you want to copy or you want to read the problems one more time. Use the same property here. 2 to the power of 4 is equal, what you have after the log is equal to base raised to that power, which is 16. So equation is that. Move 9 to the other side. Divide, that's the x. Now, number 12, we are using this formula that we had in previous sections. Log of summation is equal to log of multiplications. So log of A plus log of B is log of AB. And then what you have after the log is 10 to the power of 1. So now I need to solve this equation. Anytime you want to solve the equation, you need to have all the terms on one side equal to 0. And then I can use the factoring. Two numbers whose multiplication is -10. And when you subtract is +9. It's 10 and -1. So there are two answers. We do not accept this one, the -1. Why? Because see, if when you want to check, when you take this -10 and put it here, what is log of -10? Calculator would give you error. After the log, you must have a positive number. Calculator doesn't understand log of negative number. It gives you error. So we do not accept this negative number, just a positive one. What formula do we use for subtractions? Log of fractions. Log of subtraction is equal to log of fractions. So this would switch to fraction first. And then 10 to the power of -1, which is 1/10. You cross multiply. 1 times x plus 10, 10 times x. And then you solve. What I do is first I bring this log to that side. And then log of subtraction is log of fractions. The base is 2. 2 to the power of 2 equal to what you have after the log, 4. So now you have this fraction is equal to that, cross product or cross multiplications. You collect all the x's on one side and you solve it for x. Again, log of A plus log of B is log of multiplications. A plus log of B is log of multiplications. Now, in this case, you could cancel the log from both sides. Why? Because they both have the same base. Okay. Like if you have log of x is equal to log of 3, you could cancel this, just x is equal to 3. So here, then you just go ahead and again, there are two numbers, -7 and 7. -7 is not acceptable because if you put it here to check, you come up with a negative number. In front of the log is not acceptable. So just one answer. Log of subtractions is log of fractions. Log of subtraction is equal to log of fractions. And then 5 to power of 2 is this. You cross multiply and you solve it for x.